Hello, this is Josh Costera.
I'm Reginald Bennett.
We're here with SIE 598, augmented reality with our week 2 video with initial setup and some more testing.
We're here at the University of Maine in Orono, uh, and we'll have an overview of what we're going on with. So initially, we did some more initial setup. Last week, we talked about having some issues with computers. On the third machine we had installed it on, we were able to install with no issues. We brought in this gaming computer this time, which for a kind of a benchmark, can play any modern computer games with full settings. And it did, fortunately, it installed right to the computer without any issues this week.
Um, we did run into some issues with connectivity. We discovered if we try to connect the glasses after we've had the computer running, it would cause some issues and some restart problems. So we discovered that if we just connect them, then boot the computer, we don't have any issues.
Later on, we did for the most part, it was the VGA that killed it. We were able to do the USB a couple times, but I still wouldn't press your luck. So just have the stuff installed or actually plugged into the computer before you start. Yeah, and then we also found that we think that plugging into USB 3.0 causes issues because we kept getting restarts, and we found that when we plugged them in just a regular 2.0 port, we weren't getting that anymore.
Last week we talked about how the glasses have 2 cameras on the front, and then inside the glasses are 2 screens that are used for stereoscopic augmented reality, so you can see kind of like a 3D effect. And this week we discovered that you can actually change it from a 3D effect view to mono view, and in a mono view it disables the right camera, so it's only viewing through the left, and tracking the markers works with both stereoscopic and the mono view.
And so what you want to do is when you set this up with your computer and you have the VGA connected, you want to actually clone the screen so that you're seeing the same thing in the glasses themselves as you're seeing on your screen. It helps so that when you start your program, it doesn't have any issues. When you're running a stereoscopic view, which is the default setting, then what you'll see is your desktop in both lenses. As soon as you switch to mono, like Josh mentioned, it cuts off the right camera and the right screen. Now with that, the way that, again, we want to kind of go over the way that the glasses work. It's two cameras on the front, which are separated, 2 lenses in here, which again are separated, and that's what allows you to get that kind of stereoscopic augmented reality view, which is the cameras will capture from their angle what you're looking at and relay it to the screens. And then later, the augmented reality portion comes from the cameras relay something to the computer looks at the images, decides if it needs to alter that image at all, augment that reality, and then displays it in the 2 lenses delivered to your eyes with the perception difference, so that you get kind of that depth perception ability and the simulated visual difference, I guess. So that's the way that the camera works. Another thing too is on the inside, as we mentioned last week, there is this motion detection portion, which it made a difference when we were trying to calibrate. As we mentioned, the camera or the glasses themselves are supposed to be able to measure pitch, yaw, and roll on their own.
But we discovered that with calibration they don't actually until you plug in the gyro tracker. So we're not sure if it's something in our settings or if they just don't actually do that correctly for us. We were able to successfully calibrate it, and the tracking of pitch, yaw, and roll is pretty good. It's pretty accurate as far as we can measure it. We're not measuring it with equipment or anything like that, but just holding the glasses and twisting them left and right gives us a pretty good representation of that it's an accurate reading. We tried to get it working with Portal, the video game, the actual tracking of the head motion, but we were unsuccessful with that. But we could still play the game using the glasses in a 3D view.
Now, so one thing we mentioned that there's 2 cameras, and while a stereoscopic view, the markers that we mentioned earlier, which is this one, this is another example, and then we had our own custom one, which we'll talk about a little later on. They have to be seen by both cameras. Otherwise, the software doesn't recognize that the marker is actually in play or is active. Once initialized, and by that I mean once both cameras see that marker, it will remember the position of where that marker was last. So if for whatever reason one of the cameras can no longer see the marker, by default it will leave the rendered replacement at its last known position. So this is an issue where if the marker is too close to the camera, if it's out here, you very rarely run into the issue. But if it's close here, you can see where you might have a scenario where one camera can see it and the other one can't. And the entire marker must be seen. That's another thing that we'll talk about a little later on. None of it can be obscured. The border can't be obscured even with your finger or a part missing from the camera. Otherwise, the marker is no longer recognized. So what will happen is the system will recognize the last position relative to the screen that the marker was seen in, and it will leave it there. So that means if you're here and you kind of drift off down to the left, and that's the last part I recognize, then what it will do is it will leave that image in the bottom left part of your screen until it re-recognizes.
Something else we discovered with the reality demos, the Max Reality demos, is that you can actually have it disable. It'll stop drawing the rendered image after 30 frames, which helps us detect when we lose the image. Before it would just stay on indefinitely, but now we can actually, it goes away after so long. And also we discovered that in mono mode, you don't have to worry. It picks just the one camera, picks it up, so once it's out of the view of the camera, then it will go away. But you don't have to worry about the two cameras trying to both see the image.
So just on that, the biggest thing you want to keep in mind is if you're going to have your markers up close, just realize you might run into issues where one camera can completely see the marker, another one can't, and so you might be confused as to why it's working that way. So just ensure that whether you're using the original size markers or your own custom ones, they have to be completely visible by the camera in order to work properly in stereoscopic mode. We're going to talk a little bit about the markers here.
The markers are created with a 9x9 grid coming from the factory, I guess you could say. They all contain a unique pattern, and the biggest thing to notice is the barrier is 2 blocks thick, and there's a ratio between the barrier and generally in the pattern, so you can enlarge them as long as you maintain that ratio in the barrier. So as you can see with the one that we made, this is actually isn't the correct ratio, but it still is recognized by the software because it can detect it well enough that it says, okay, that kind of looks like the marker, so I'm going to render the image. And so you can enlarge them as big as you can either print them, or as we did with Legos, you can make them even larger.
Now by default, all the markers that come in the library with the Vuzix software shows them all in black and white. But as you just saw with that Lego pattern, the background was green. So not an issue there. So what we think right now, we'll do further testing, is that it just needs to be a high contrast difference, and we'll check to make sure that whether the black part actually has to be black or if it can just be a dark color as compared to a light color. But as right now, we can at least tell you that the inside being green had no issues, which you'll see in a video later on. And then what we also found is that the markers are actually made up of both a top and a bottom part. And that's last week we said there were 64 of the S markers, which are the static markers, and I believe 62 of the mobile markers. Now, as for what the S and M means right now, we haven't tested that yet, but those are different types. And as you can see on the slide here, the top set of markers, you can see the top portion is the same, while the bottom portion has changed, and that's 2 different markers. But if you look at the bottom part, you can see that the bottom portions are the same, while the top has changed. And so what we found was, if you're going through the first set of 64 markers, you'll have that top pattern and then 16 different bottom patterns, and then it'll iterate to the different top pattern, and then again 16 different bottom patterns, which are all just repeats of the originals. So it's interesting to recognize that. As was mentioned earlier, Josh said that this grid right here is actually kind of a second version 2. It's off by 1 grid square, or by 1 Lego. This should all actually be moved up 1. But what we found, what was interesting about it, was that the system would still recognize it as I believe it has some type of error detection in it, which is necessary. Later on you'll see in the video that you can rotate the markers left and right, and it will actually proportionally rotate the 3D replacement or injection. And I guess let me explain that real quick. So when you put the marker up, you'll see that in the demos anyway, that some type of 3D rendering occurs, and that is relative to the size of the marker. And then it is also relative to the rotation of the marker, as long as the cameras can recognize the pattern.
So going on with size, the other thing we discovered is these standard markers, which are about 3.5 inches wide, will be recognized by the camera up to 15 feet away, but they'll only be tracked to about 9 feet, and then beyond that, it'll recognize it, but if you try to move it, it'll lose it almost instantly. And when we created our larger marker, we could actually get about 20 feet away and still have it recognized, and that's right now is a limitation of the room we're in because we couldn't go much farther. But it also tracked up to that 20-foot distance, so the bigger markers make it easier for the camera to recognize and track the image.
You know, it's just standard rules for being successful. But as we mentioned earlier, if you're going to be close to your markers, you know, just be careful that both cameras can see. The other thing we noticed is that while we could track out to 15 feet, which you'll see in the video, it was much more reliable inside 9 feet, you know, with swaying the position back and forth. And I think that has a lot to do with the resolution that the cameras capture. I believe with probably the newer models that have better cameras, you can probably go further because it's just all about pattern recognition.
So I think we just...
And then, so something else that we tested was we had a large black foam background that we stuck the marker to, and we noticed a dramatic drop in frame rate when we did that. And we believe that to be because when you see a large black border, kind of like in the markers, then the system starts trying to recognize, okay, well, hey, what pattern is in there? And it's not finding one, so it continues to waste cycles trying to recognize, okay, what is this huge, like, black square? What pattern am I supposed to be seeing? And so we saw a frame rate drop. And then what was also interesting is that when we flipped it around, that foam actually has like cones on it, which have, in the light, obviously, they reflect white a little bit. And so I think that even made the system more confused because now it was seeing a black border with a bunch of white values in the middle, and then it was trying to recognize a ton of different patterns and just wasn't finding any. So that's something to be careful of too, is in your situations. Whatever patterns you're looking for, you can find static or false positives, I suppose, in your environment. So try to cut that down if possible in your testing environment, and then obviously we'll have to mitigate that in a real life situation later on. We did talk about the markers warping. You'll see it later on, but you'll have the 3D render on it. And that's you know, this is what it looks like flat. If you go like this, the system will actually see that, okay, the picture has changed in some way. Let me calculate where that change happened, and it'll actually rotate the 3D rendering based on what it sees in the marker. So that's why those markers have to be unique.
So in our Max Reality is part of the software package that comes with it, and they have demos. And like we discussed earlier, the F3 button will toggle the blackout mode, which once the marker leaves the image for 30 frames, it basically stops rendering the graphic that is there. So you can tell when it drops it, or even using distance, you can tell when it drops the recognition of the marker. And F4 toggles the mono mode, which, like we said, will disable one camera and only use, you won't get the stereoscopic view. So for me personally, I don't really notice too much of a difference in it, besides the fact that on the screen that I can watch it's split, but when you're in the glasses, it looks kind of the same. You lose a little bit of the 3D effect, but I notice a better performance with mono mode because it's not trying to render both cameras. So that is one benefit of mono mode. If you don't need the stereoscopic vision, then you can use mono mode.
So right now we'll show you a couple tests we did using a different recorder. So we'll switch to that now. So here in video 1, we're going to show you a little bit about our marker setup. You can see the lab setup we have. You see when we look down at that marker, that it went ahead and put the render on there, and you're going to again see that issue where if it's too close and both cameras can't see the complete marker, it's going to render it in the last position.
And now both cameras can see the marker, so you're getting a full render, and you can see that we can rotate it, move it around, and it tracks reasonably well. And when it leaves the camera's field of view on left or right, you can see that the marker the image stays where the marker was last seen by both cameras. This is how we discussed in our slideshow. And you can see the rotation. You can hold the marker upside down and it'll still work. And we're just kind of moving around. You can see how the object actually rotates in there. The cameras lost it, so they stopped rendering it and left it where it was. So again, that pattern recognition is looking at, okay, hey, here's the
the source pattern, if I change the ratios of width, then that clearly means that the pattern has turned some amount. So it's a pretty powerful image recognition algorithm I got going on. But here we'll move on to video 2. In video 2, you quickly saw some red text at the beginning. That was the help menu if you hit F1 while in the demos.
Right now I'm slowly backing away from the camera, testing to see where the marker will no longer be recognized. And when I come up on about the 9 feet barrier, you can see it'll start to stop recognizing it. And also you can see me kind of moving it to make sure we're actually tracking it. It's not just staying in one position. And right there, the marker was lost. And we're going to mark that so we can measure it for later purposes. And now we switch to our custom-made marker, which is much bigger. So I can continue to back up and get to about 15 to 20 feet away from the camera and still be able to track the marker.
So there you go, going back, still doing motion. But as we discussed, it's really the resolution of the cameras and what they can do. So even though the marker is bigger and we got, a few more feet, 5, 6 more feet out of it, probably given a little bit better lighting conditions, maybe with the contrast being black and white instead of green and black, then we wouldn't be able to get further. But again, you have to be cognizant of 1, the capability of the camera, and 2, just how big and how clear your patterns are. You're again seeing that kind of glitching that occurs when both cameras don't have full picture of the pattern. If any part of that picture, like if you were to put a finger completely across that border, it would not be recognized. We just wanted to kind of show you the 2 different patterns in relation to each other, as well as the 3D rendering all on kind of one screen. So now we'll go back to our slideshow presentation. Alright, so those are the tests that we did. Just a few more comments for this week on what we found out in our tests.
So we attempted to get the SDK running, and we discovered that it comes with examples. Unfortunately, they don't work right out of the bat with Visual Studio 2013, so we're going to have to play around with that and see if we can get them working. And part of the problem is the samples or examples that come with it don't have very much good documentation, and I couldn't find anything on the internet, I know. So it'll be an exploring process.
Another issue is, with some lack of information on the internet. It's the same thing for just projects in general. We found maybe about 4 or 5 videos online, the projects that people have done, but not too much in the way of comments, forums, or projects that people are freely talking about. So we have reached out to a couple people there on YouTube to see if they can give us some information about some projects they did 2 or 3 years ago. Hopefully they have some good documentation. And then again, lastly, we'll kind of bring up the test we did with Portal. Went ahead and we had to do some kind of overly convoluted copying of files from different folders to different places. Once we have that all in place, we booted up Portal. Portal boots up with 2 sides of the screen showing, and then you can get stereoscopic view in Portal. Portal being an older game, or maybe that's not the issue, but it is interesting that the 2D menus don't react to where they're rendered. So normally you might have a menu that's in the middle of the screen. Even in your view, in your stereoscopic view, if you go to click where you think the menu is, that's not right. You actually have to click where the menu exists true to the screen, the actual computer screen, not to the split screen that you're getting from the glasses. So that's probably just something in Portal itself that it's not taking into consideration the fact that it's split into 2 screens. But you're going to have that type of issue when you run into applying these. So that's something to look out for when we make our own custom applications. So that's it for this week. We'll have another video next week.
Hopefully more progress and actual working demos, but we'll see.
Yeah, have a good one.